Hello, my name is Cesar Romero. I work as a software architect at ITDevCon in the city of Blumenau in Brazil. I have more than 28 years of experience in system development, and in the last 10 years I have been working as a software architect. I think it is worth giving a brief introduction about the company I work for. I believe that by the image you can already imagine what we do here. Well, at ITDevCon we code, but ITDev produces beers and other drinks, and those are just a few of them. ITDevCon is the IT company of the brewery ITDev, with more than 1,600 employees, combined with other companies in the group, startups and joint ventures. There are more than 5,000 employees working with software development for Grupo ITDev only in Brazil. ITDev is a Brazilian beverage production company that is part of the Group AB InBev, the largest brewery in the world, with approximately 630 beer brands in 150 countries. My goal today is to present to you a brief introduction about what is clean architecture and a project created in Delphi implementing clean architecture. I will not go into details of the basic concepts involved today for two reasons. We have little time to talk about everything that is necessary, and I did another presentation on this topic, but in a more introductory version that explains in more detail the basic concepts. This presentation was at Coding Bootcamp 2023 on the last day of August 18th. So if you don't know all the concepts presented today, I invite you to watch the recording of this presentation on YouTube, which is available on the Embarcadero channel and on my own channel. My goal today is to present how to create high-quality systems using clean architectures. How to create systems that are easy to maintain, extensible, testable, and consequently with less bugs. To achieve this goal, we must use good practices, design patterns and system architecture consolidated in the market, and proven efficient. This is not an easy task. We face many challenges, and as each developer can implement a task differently, the objective result can be the same, but the code quality can vary a lot, as well as the number of bugs. The clean architecture, proposed by Robert C. Martin, often known as Uncle Bob, in 2018, is a design paradigm that promotes the separation of concerns within a system, making it more modular, flexible, and maintainable. This diagram is a visual representation of the different components and layers in a software architecture. The image is divided into two parts. The left side shows the different layers in a software architecture, and the right side shows the control flow between the different components. The image was designed to help developers understand how the different components in a software architecture interact with each other. The left side of the diagram is a circle divided into four layers: devices, portals, entities, and use cases. The right side of the diagram is a flowchart that shows the interaction between the different components in a software architecture. The entities and use cases are part of the inner layers of the circle that represent the domain and business logic. They are enterprise-wide business rules, or things that will always be true or static for this application. The entities can be an object with methods or just a collection of data structures and functions. They encapsulate the most general or high level and therefore are the least likely to change due to a change to an outer layer. For example, the core functionalities of an application would not be changed by switching its front-end framework to React or Angular. The portals and devices are part of the outer layers of the circle that represent mechanisms that allow data to flow in and out of the system. The portals are interfaces that allow data to flow between the system and external systems. The devices are interfaces that allow data to flow between the system and external devices. The clean architecture aims to make it easier to create stable applications even when external elements such as UI, databases, or external APIs are always changing. My goal is to show you how it is possible to take advantage of clean architecture to make developers' work easier, how to create extensible and easy-to-maintain systems, how to onboard new developers to the team more easily, as well as in Steve Ardalis Smith's quote. Make what is right easy and what is wrong difficult. Here are the principles of clean architecture. Separation of concerns. One of the primary goals of the clean architecture is to separate concerns, ensuring that each component of the system has a distinct responsibility. This makes the system easier to understand, modify, and maintain. Dependency rule. The inner circles should never depend on the outer circles. This means that the core business logic, entities and use cases, should not depend on external frameworks, databases, or other volatile elements. Instead, external elements should depend on the core business logic. Independence of frameworks. The architecture does not rely on specific frameworks, making it possible to switch or upgrade without affecting the core business logic. Testability. By decoupling the core logic from external frameworks and tools, the system becomes more testable. Business logic can be tested in isolation, without the need for external elements like databases or web servers. Independence of UI. The UI is just another external detail and can be easily changed without affecting the underlying business rules. Database agnosticism. The system should not be tied to a specific database. By keeping database details in the outermost layer, it's possible to switch databases without affecting the core business logic. Flexibility. The separation of concerns and the inversion of dependencies make the system more flexible, allowing for easier changes, extensions, and scaling. In essence, the clean architecture emphasizes the importance of keeping the core business logic pure and free from external influences. By doing so, the system becomes more maintainable, scalable, and resilient to changes in technology and requirements. And here are the fundamental elements of the clean architecture. Entities. These are the business objects of the application. They encapsulate the core business rules and are not influenced by external factors like databases or frameworks. Use cases. These represent the application-specific business rules. They describe how the system operates, detailing the actions that can be taken and their allowable sequences. Interface adapters. This layer converts data from a format most convenient for the use cases and entities, to a format most convenient for some external agency such as a database or a web server. This might include things like controllers, gateways, and presenters. Frameworks and drivers. This is the outermost layer and is generally composed of frameworks, UI, database, web servers, etc. It's where all the I/O components reside. The architecture is often visualized as a series of concentric circles, with the innermost circle representing entities, followed by use cases, interface adapters, and the outermost circle representing frameworks and drivers. I created the Shop on Web project in Delphi, which was directly inspired by the similar named project eShop on Web in .NET and C# available on GitHub. My version focuses on the implementation using design patterns, solid principles, clean code, and clean architecture. This project is not created using any web API framework. Initially it was, but I decided to abstract this dependency and show in a radical way that it is possible to develop business rules with unit tests, without external dependencies of libraries or components. But that does not mean that you will not have to do it. What I mean is that the focus should be on the customer's need. And as Uncle Bob says in the book Clean Architecture, the database, frameworks, and even the UI should not guide the implementation of the customer's needs, but rather the use cases of their business rules. This project is separated into packages. There is no executable in this project yet, because we will focus on the abstraction elements of the project. Although there is no executable, GUI or web, all the necessary elements for this integration are available, leaving the developer the choice of the framework that suits him best. The project structure is organized by features. I like this structure because it shows us what the system does, without the need to enter several files to find out what the project offers. I will take a step back and show another version of this same project that is organized in layers. This structure is also clean architecture. It contains all the proposed elements, but the files and classes are separated by functionality. See that the classes are separated by functionalities, entities, services, specifications, use cases. You have probably seen this model in several projects. It is common in web projects. The classes are separated into folders. Like in MVC projects, you have the folders models, views, controllers, and so. To do maintenance on basket domain, it is necessary to go through several separate folders to find where the change should be. This requires more effort from the developer, having to navigate through different folders to understand how the system works and the dependency between the classes involved. Going back to the structure organized by features, can you see the difference? In the root of this project, we have only two folders, common features, and from features we have each domain of our project, where all the files related to each feature are together. It is very easy to understand the content of the project. It is easy to maintain without running the risk of changing code from other classes by mistake. This model is called by Uncle Bob Screaming Architecture, and the concept refers to the idea that the architecture of a software should clearly reflect its purpose and functionalities, without being influenced by technical details, such as frameworks, databases, or user interfaces. The architecture should scream what the software does, and not how it does it. This organization of the project reduces the coupling of classes and increases the cohesion between related classes. You will see the concern about these important topics throughout this project. I also want to draw attention to the use cases of the basket feature. In the previous version, all use cases were in a single class called basket use cases. In this version, each use case is implemented in a separate class. A use case represents a specific business need and is responsible for orchestrating operations in classes to execute this functionality. What do you think best represents a business need? Log in or authenticate user? Create order item record or add item to basket? Delete order record or cancel order? Entities. They are objects that have a unique identity, and that can change state over time. They represent important concepts of the domain, such as customers, orders, or products. They are identified by their ID, not by their attributes. Aggregates. They are groups of related objects that are treated as a unit of consistency and transaction. The aggregate root is the main entity in an aggregate that acts as a guardian for all access to the objects within the aggregate. In other words, the aggregate root is the entry point for the aggregate, and the only way to access the objects within it. For example, basket and basket item compose a unit, and therefore this composition must be treated as unique. But remember, aggregate is also an entity. Value types. They are objects that do not have a unique identity and that are immutable. They represent properties or measures of the domain, such as colors, addresses, or quantities. They are identified by their attributes, not by their ID, as you can see in the tCatalog item details record. In Delphi, records are the best way to implement a value type, but it is important to note that they must be immutable. If there is a need for change, it must be replaced by another instance with new values. And since they do not have an ID, they are part of an entity, often represented by one or more properties. In this project, I use the iAggregateRoot interface to identify not only composite objects, but also entities that can be persisted, in the sense that they represent the root of a class. The idea is that we can block the attempt of direct persistence of tBasket item that may happen due to a bug introduced in a maintenance. Every time it is necessary to perform an operation on a tBasket item, it must occur through the tBasket class where the business rules are implemented. Do you remember what I said before? Make what is right easy and what is wrong difficult. This way we use the compiler to prevent a bug from being introduced into the project. Let's talk about business rules. The business rules must be implemented in entities, period. Well, not so much. It is important to understand context and put the business rules in the right class, be it entity, aggregate, value type, or use cases. There is an endless discussion about anemic entities and entities with business rules that you may have seen on the internet. People who prefer anemic entities put the code in services, and the entities have only properties. And people who are against anemic entities usually say that in OOP objects have data and code. This discussion never ends and both sides are right. I have worked with both models. Both have advantages and disadvantages. Many times you are forced to choose a model, either by limitation of the use technology or because there is a predefined coding standard and the company does not allow to change, either for convenience, for long-term standardization, or even fear of introducing bugs. But the truth is that everything will depend on the context. The important thing is that the choice is conscious, and not be forced by a framework, or not have the intention to do it in the chosen way. Let's quickly review the difference between concepts often confused, which make implementation more complex and hinder maintenance, as they force the use of code that should be in another layer of the project, or even violate some principles such as dry, bringing repetition to the code. Business rule. It is a logic that defines or restricts some aspect of the business, such as, a customer can only buy a product if they have enough balance in their account. A business rule must be implemented in the software domain, that is, in the layer that contains the entities, aggregates, value types, and use cases. A business rule must be independent of technical details, such as frameworks, databases, or user interfaces. Input validation. It is a check that ensures that the data provided by the user or by another external source are in a valid and consistent format, such as, an email must have the @character. Input validation must be implemented in the outermost layer of software, that is, in the layer that contains the input and output mechanisms of data. Input validation must be specific for each type of data and source. Database rules. They are constraints that ensure the integrity and consistency of data stored in a database, such as, a foreign key must reference a valid primary key. Database rules must be implemented in the layer that contains the repository or database adapter. Database rules must be specific for each type of database and model. A definition of business rule that I like is that business rule is more volatile than a validation. From the moment you implement in the user layer, an input validation, this will rarely change. But if the code can change due to a business need or a change in law, then it is a business rule. Now, let's get back to the project implementation. I put on this slide some code examples of the entities tBasket, tBasket item, tCatalog item, and torter. In some of them I used the guard pattern. The guard pattern is a design pattern that aims to protect the integrity of data and prevent execution errors by checking the preconditions and post-conditions of the methods. A precondition is a condition that must be true before the execution of a method, such as, a parameter cannot be null or negative. A post-condition is a condition that must be true after the execution of a method, such as, a result cannot be null or invalid. The guard pattern consists of creating classes or methods that encapsulate the checks of the conditions and throw appropriate exceptions if they are violated. These classes or methods can be called guards, assertions, or invariants. The goal is to make the code more readable, secure, and easy to maintain, separating the validation logic from the business logic. Use cases are descriptions of how a user interacts with a system or product to achieve a specific goal. They show the success scenarios, the failure scenarios, and the critical variations or exceptions. They can be written or visualized with the help of a use case modeling tool. From a business point of view, use cases serve to manage scope, establish requirements, communicate strategy to stakeholders, solve potential problems, prioritize elements and functionalities. From a development point of view, use cases serve to visualize the system architecture, separate business logic from technical details, test and validate the system, reuse and modularize code, document and maintain the system. To name a use case, it is advisable to use a verb followed by a noun that indicates the user's goal, such as buy product, register user, cancel order. The name of the use case should be clear, concise, and consistent. Some examples of good use case names are create account, send message, evaluate product, request refund, change password. Some examples of bad use case names are login should be authenticate user, process payment should be pay order, add item should be more specific like add item to cart, validate email should be a precondition, not a use case. Manage inventory should be divided into smaller use cases, like consult inventory, update inventory, remove product from inventory. The specification design pattern encapsulates query details in separate classes as part of the domain model. This pattern can be used to solve the following problems: duplicate query logic throughout the application, growing repository implementations that keep adding custom query methods. Additionally, individual specifications may be more easily discovered and better understood than complex SQL queries littered throughout the application's layers. This project uses the specification design pattern to decouple the queries from the infrastructure or database layer. This means that the queries are defined in the domain layer, using classes that implement the iSpecification interface. These classes specify the criteria, filters, includes, paging, and ordering of the queries. The infrastructure layer contains a generic repository that can execute any specification, using the tSpecification evaluator class. This class translates the specification into an expression that can be executed by a ORM framework, or to SQL queries to be directly sent to the database. The advantage of this approach is that the queries are independent of the database or framework used and can be reused and tested easily. The queries are also aligned with the domain model and the business rules, rather than being driven by technical details. And this is all I wanted to show you about the domain project. The other classes are implemented in the same way, or their purpose is obvious that it is not worth talking about them in our short time available. I will also not talk about the infrastructure project. This project contains the implementations of the interfaces defined in services in the domain project, to avoid coupling and external dependencies in the business rules, like repository, send email service, external API clients, file system and date-time services, configuration access, and so on. These dependencies will be linked at runtime through dependency injection, a topic that is not part of this presentation due to lack of time. But if you watched my presentation at the Embarcadero Coding Bootcamp, these concepts are detailed and available in the project on GitHub as well. Now let's get to know the public API project. First of all, I'm not happy with the name of this project. I should change it soon, but I haven't found an alternative that pleases me yet. But I'll solve that as soon as possible. The purpose of this project is to be a layer between the domain and the executable that will have the components or library of API or web application. It can be any project, open source or commercial. This project tries to implement everything that is possible for an API, without depending directly on a specific library, being closer to the business than to the library in a way that the dry principle is not violated during the specific implementation, but use intelligently the classes already existing in this package. The final idea is to have something like a binding between these two layers. Now let's understand the content of the project. In it you will find endpoints. Yes, you've heard that right, endpoints, and not controllers. Along with the endpoints you will also find models that in this context are data transfer objects or DTO. I just like model more than DTO, and I think the name fits in this context. You will also find request and response objects and adapters to transform the models between layers. There are auto mapper libraries for this functionality, but I prefer not to use them. They add overhead and make requests slower, and often the rules end up being even more complicated than the implementation of the adapter design pattern. Okay, but how much slower? I have seen cases of up to 100 times slower. If we are talking about 100 times slower than some nanoseconds, this is still imperceptible. But if we are talking about minutes, then this becomes a problem. Honestly, I think that if it is used to map the user interface, where it makes requests a few records at a time, it's fine, the slowness will not be noticed. But for an API that can process hundreds of requests carrying many records, it is better to avoid. I also found room for the inclusion of middleware in this project, but I will not go into details about it yet, because when implementing the integration with frameworks, it may not be so useful, and if it is not to meet most cases, it does not make sense to be in this layer. In this project, the classes are also organized by feature, as well as in domain. You can find in a folder all classes associated with a specific feature. I created a few versions of the endpoints interface to adapt according to the need, from no argument or result to 3 arguments and 1 result. Each endpoint represents a possible request for the API, and it can be easily mapped to controllers or calls through anonymous methods and minimal API, if desired. The HTTP GET attribute, as well as the corresponding ones for the other HTTP methods, define the verb and the URI template of the REST resource. The HTTP operation attribute aims to document and serve for integration with OpenAPI using Swagger or another similar library. To use the information from these attributes, it will be necessary to implement the bind using RDTI. I initially implemented it in code through other interfaces to avoid using RDTI, but this pattern of attributes in classes is very readable, and not having to navigate through the code to find the URI is very practical, not to mention that it can increase the chances of unintentionally changing during code maintenance, increasing the chances of a regression. The iEndpoint interface defines only one handle method, and the request and the services necessary to process the request must be injected into this method, thus avoiding the coupling of classes, leaving the code ready to be extended if necessary, being able to change the implementations of services without having to change the handle method. In this example, an instance of iRepository tCatalog item is being injected, and I know some people who would complain about that, saying that handle cannot access the repository directly. But I see no problem in using repositories to execute queries. The integrity of the business must be guaranteed by the domain layer, but there is no need to instantiate intermediate classes for queries. What you need in these cases are only specifications for queries. A good practice here would be to create a read-only version of the repository through an iRead-only repository interface. This is enough to ensure that someone who is not familiar with the project standards does not try to make changes through these repositories. This handle implementation of the catalog item list paged endpoint contains basically everything we can do in this layer. It has request, response, filters created with information received by the request, pagination, and response with HTTP status. It is worth noting that we are not using try/except on purpose. Here is not the place for them. This should be only in the implementations of external services in the infrastructure project, or in specific middleware for exception handling. That's the case of the middleware that I said I wouldn't talk about, because I'm not sure it will really be useful in this layer. Anyway, we shouldn't add try/except here. The request, response, and model DTOs are just helpers used to transport the request, return the response, and in the case of the model, it also serves to not expose the internal structure of the business entities outside the application, increasing security in relation to unwanted information leakage, as in the case of data protection law. Using business entities directly greatly increases the chances of unwanted information leakage, so this separation of concerns is a good practice. Many times this separation and translation between layers is seen as unnecessary work, but in addition to ensuring information security, it also separates responsibilities, and in this case I am talking specifically about the single responsibility principle, which in this case, the model and the entities have different responsibilities, and even having an identical structure, they have different reasons to be changed, and the reuse of entities can result in classes containing more information than they should, carrying the responsibility of other layers, thus increasing coupling. The API package contains some helper classes, just to make it easier to implement the endpoints. So I would like to finish the tour of this project by showing the implementation of the adapter design pattern, used to transform from the structure of the entity tCatalog item to the tCatalog item model, simple, direct, and efficient. I made a point of showing this simple code, because I know that the temptation to use an auto-mapper is great. Initially it seems very convenient, when the classes are identical, but from the moment you need to do conversions and need to implement specific mapping rules, everything gets more complicated and slower. This diagram shows the layers of an application created with clean architecture. Note that the domain layer does not depend on any other layer, allowing unit tests to be created without external dependencies. External dependencies should be in the infrastructure layer, where integration tests will be performed, and in the user interface layer, functional or end-to-end tests are conducted. Notice the dashed red line between the user interface, infrastructure, and the application layer. It represents a runtime dependency, which will be resolved by dependency injection, simplifying the process of creating mocks for unit tests to avoid external dependencies. This is a very important detail, because the most efficient and economical way to test is by writing unit tests correctly. By isolating the business rule in the domain package, without external dependencies such as database and using mocks, we can achieve 100% coverage with unit tests. Above, the integration tests, they should be executed in the infrastructure layer. These tests are more difficult to create and should test the integration between the layers. Note that at this moment, the user interface is not being tested yet, only the integration between the application resources. And at the top, the functional tests, these should be executed from the user interface, even more difficult to create and automate, and often of low reutilization. To create the unit tests, I am using DUnitX Spring, mocking and test insight to run the tests continuously as I code. Running the tests continuously is simple, because these tests cover the maximum possible lines of code from the domain, which has no external dependencies, so the test execution is continuous and instantaneous. This way I can discover as soon as possible if a regression was introduced in the code. You may have noticed that some tests failed, and there are also some warnings in the test insight window. They have reasons to be like that. The warnings are from tests without assert, which are tests with mock services, where Spring mocking validates if the code flow was called with the correct arguments, but does not return any value, as in the case of procedures. And the failing tests are tests created with TDD, of classes that have not been fully implemented yet. These specifically are tests of specifications, and the evaluator is not 100% complete, so the test fails, but TDD is like that, red, green, and refactor. It is worth to mentioning the project structure, organized by features just like in the domain and API packages. All tests and helper classes like builders are grouped by feature, basket, catalog, and order, and in the subfolders by functionality, builders, entities, specifications, and use cases. These are simple tests. On the left, the use case of adding items to basket is validated, and on the right, we validate if the expected exception is thrown if the user tries to save a negative quantity. In both cases, if the expected behavior is not met, the test will fail. With the test case attribute of DUnitX, you can make a combo varying the input for your test, running each one individually and having the result of each execution. This feature is great to avoid repeating similar tests with different arguments, or the need to create more complicated tests by running loops of test interactions, and in the end the results get mixed up, making it harder to identify which tests failed. Using a framework for mocking is amazing. It helps to keep your code decoupled from the specific implementation of services and external dependencies, helping to isolate the use cases by setting up the tests individually. In this test, the mock is created, configured, and finally validated. The setup configures the result of the call to the getById method, and the received validates if the delete method of the repository was called exactly once. If any configured step is not executed, the test will fail. And that's all. Unfortunately, time is short, and I can't show you everything I would like, but I hope that somehow I can have inspired at least some of you to learn more about clean architecture and enterprise design patterns. This project is still under development. It is part of a personal project, and I am still defining its destination. Eventually I will make it available on GitHub. It is not public yet. As soon as I complete some more steps and documentation, it will be published, but I can give access if you asked me. So if you are interested, if you have any questions, please contact me. On this final slide you can find my email and my social networks. To conclude this presentation, I would like to leave you with a motivating and inspiring message. The use of design patterns and unit testing with Delphi is more than just a technique or a tool. It is a way of thinking and creating systems that are efficient, reliable, and sustainable. It is a means of expressing your creativity, skill, and passion for programming. As Uncle Bob, one of the creators of the clean architecture concept, once said, "The only way to go fast is to go well." In other words, the only way to move quickly is to do it well. I hope this presentation has inspired you to do things well and efficiently in your Delphi projects. Thank you very much for your attention, and until next time.
I believe you were so clear in your presentation that doesn't look like anybody got any questions for you.
Oh, really? I'm so glad you guys could understand me. That's so many issues to talk about in this so little time. And if you need to understand better, you can watch my presentation Coding Bootcamp also.
Okay. We have one question.
Hello, I'm Giorgio. I have a question about the menu, the book that you presented in the first slide. I try to find in the Pact Pub if it's present, but I don't find it. So the question is, where we can find the book?
The book Clean Architecture.
Yeah.
Yes.
Well, actually, it is. Let me see where I can find right now. Architecture book. I have this book for so many times. Well, I can see it's in Amazon.
Okay, thank you. Altre domande?
You have a digital and the printed version in Amazon.
Okay, thank you.
Welcome.
Altre domande? Un applauso? Okay. Thank you very much. Thank you.